Good afternoon. I promised today that I would go over the question number 10 from I think it was the 3.3 homework, this racetrack problem that I suspected you all would maybe need a little help with it. But it basically says if as they prepare for a NASCAR race or a Formula One race, and the car is going to be following this curve, and there's basically bleachers for the fans built. How are they going to put the bleachers in a place so that no one gets hurt by a car if it flies off the track or something? So they basically say the car is going to come in like this, and the first thing they say is uh, physicists have determined that the drivers are most likely to lose control as they're coming into a turn at the point where the slope of the tangent line is 1. So we're going to start here knowing that our original function f of x is x cubed plus 3x squared plus x. We could find the derivative using the power rule and the addition rule. It would be 3x squared plus 6x plus 1. And essentially they're saying the trouble point is when this is all equal to 1. So I'm going to set this all equal to 1. And you might notice that when I subtract 1 from either side, you're left with 0 equals 3x squared plus 6x. Well, that's very factorable. I'm going to factor that as 0 equals 3x times x plus 2. And that creates two possibilities where 3x is 0. So that would be when x is 0. And there's another moment where x is negative 2. And just looking back at this graph, that does make sense that essentially what that says is we would see the graph, the slope of 1 at negative 2 right about there, and also at 0 right about there. So that makes sense that there would be two moments where the slope of the tangent line was 1, but we're really only concerned about this first one, and that's going to determine if this is going to hit these bandstands. To illustrate this, I put this into Desmos just to be a little more clean about it. Really just that we're avoiding that point right there. And what we've already found is that this happens we're talking about when x equals negative 2. So we've got a couple things going for us. We know that the slope of the line of the tangent line right there is 1. We also know it passes through the point 2, and if we plug in negative 2 into the original function, we know that it also has to have f of negative 2 is going to be negative 2 cubed plus 3 times negative 2 squared plus negative 2. And that's going to be 8 plus 12. Something went wrong here. No, that's negative 8 plus 12 minus 2. So negative 8 plus 12 is 4, minus 2 gives us 2. So we know that the point when x is negative 2, f of x is 2. So we know that that point is on our tangent line. We also know our tangent line is, let me switch colors just to not get it too muddy here. So we know essentially the line will be y equals 1x for that slope of 1 plus the y-intercept. But we also know that this is all 2 when x is negative 2. So it's pretty quick math to just say that would have a y-intercept of 4. Let's peek over at our graph again on Desmos, because I did actually create this line in Desmos. So there's our line, y equals x plus 4. Makes a lot of sense. There it is, right at negative 2. Is a slope of 1. You can see even how it crosses all those squares perfectly evenly. That would be our tangent line. And you can see that it is not at risk of hitting this point or anything to the left of that point. So it looks like, for now, those fan setups are safe. So that's going to answer the next couple questions. That when you ask is, so first of all, y equals x plus x plus 4 would be the answer to this question, the first one. And then to determine whether the spectators are in danger of the scenario, find the x coordinate where the tangent line crosses y equals 2.8. So we could just do 2.8 equals x plus 4. And if we subtract 4 from either side, we get negative 1.2 equals x. In other words, again, let's peek over at that Desmos, just say that is this point right here, that when x is negative 1.2, that gives us that 2.8. But it's really just confirming what we already saw, that that line does not hit it. Okay. And new share. Back to the document. So this are, according to this, it's safely to the right. So the next part of this says, what if a driver loses control earlier than the physicists project? Suppose a driver loses control at this point. What's the slope of the tangent line? So this problem is kind of nice that we already have an XY pair that we know is on our tangent line. The second part of this is to just say, what is f prime of negative 2.5? Well, we know that the original function, 3x, we already did this, 3x squared plus 6x plus 1. If f prime of x is 3x squared plus 6x plus 1, then this at negative 2.5 would be all this. And I already did this. That all works out to be 4.75. So that's actually the answer to this one. That the slope at that point is 4.75. And then the other thing you need to know is, well, that's the slope of the tangent line, but is this gonna hit people? So let's go ahead and continue to find the rest of it and just say, well, we're talking about y equals 4.75x plus b. And we know that y is 0.625 when x is negative 2.5. And I did this in advance, but this all works out to be b is 12.5. So our equation would be y equals 4.75x plus 12.5. If you need a second to figure that out, just pause the video and figure it out. Going to switch over to a new share. And I have included this line as well, 4.75x. Let me get rid of the green stuff. And then you can just see by looking at the graph of it doesn't hit this exact point, but if you remember from the original image, there were buildings all along here. So at this point, that would dictate that this is unsafe and they should be moved. Hope that helps. Enjoy the video, everybody in my class that asked for it.